Hi, my name is Lamont, and I'm a member of the Uniminds team. Together with Khutso, we developed the poster that you see on the right-hand side. The South African SDG Hub has a classification platform that needs to be improved so that policy formulation, implementation, and funding of related research can be improved through research-based evidence. Various machine learning models were developed, visualized, and deployed to answer our research questions. We were provided with training data from the South African SDG Hub. However, we needed to supplement this data. So abstracts and SDG tags were scraped also from their website, and that data was clean and then added to the data that they provided us with. We also sourced authoritative data from the United Nations in terms of how the goals were defined. Firstly, through descriptions of their targets, and then secondly, through metadata descriptions for each of the indicators on the targets. Separate features could be specified to train, tune, and perturb the models. In particular, we took the abstracts. We could also select the target description separate from the abstract, or we could concatenate the two together. We found that we had to resample our training data so that the count of each class could equal the count of the Sustainable Development Goal number 1, which was 9,711 articles. Our initial models looked at the multi-class problem where one goal was allocated for each article, and we developed models for logistic regression, random forest, and support vector machines. These were trained with 5-fold cross-validation. And towards the end, we looked at one versus rest classifiers to call the following multi-label models, where multiple goals were allocated to each article. Our findings started with the data imbalance, where we saw that articles ranged from over 43,000 for SDG 16 to as little as 440 for goal number 14. By scraping the data from the website, we noticed that goal 3 could be improved and actually went up the ranking on the Pareto chart, but that still didn't lead to a great improvement in the predictability of the model. From a testing perspective, we had 33% holdout data, and accuracy was measured across all the goals for each sample, which was quite a stringent measure. The results that we found was that the multi-label linear support vector machine classifier was the best performing model with a 66% accuracy. But I'll now ask Khutso just to take you through the proof of concept and demonstrate that for you.
Thanks, Lamont. My name is Sepuru, the second member of the Uniminds group, and I'll be showing you our deployed application using streamlit. So on a high level, this application allows you to input a text corpus of any size, and it will classify it according to one of the Sustainable Development Goals. And the tool uses two models, namely logistics regression or random forest. So I'm going to go ahead and do the demonstration. So before we start, we have a choice of retraining the model or the vocab, but it's important to note that retraining takes about 3 minutes 36 seconds for the complete streamlit application to load until completion, versus using pre-trained saved models or vocabs that takes 15 seconds to load. So only really use that if the parameters in the sidebar require you to do so. Okay, so we start off by loading. We have to choose a file between the original dataset, which was imbalanced, or the resampled dataset. And then you also have to choose a feature. So we have 3 options. So one from the original data set, which only had article abstracts. And then we went on to get the authoritative data from the UN website, which had the target descriptions per SDG. And then we also have a feature set, which is made up of a concatenation of the article abstracts and their relative target descriptions for that SDG. Okay, so I'm going to go ahead and choose the resample dataset. We just wait about 15 seconds for the streamlit tool to load. So you just have a look at here. Okay, so the tool is done running. Then I'll just walk you through. So what we have here, after loading the dataset, we have a histogram, which shows you the class balance. And for this dataset in particular, because we resampled it according to SDG 1, so all the samples from SDG 1 to 16 have 9,711 data points or samples. And then going down, we have a tabular representation just showing the fraction of the classes of each SDG in the data set. Then going on, the tool then transforms the data using a vectorizer of choice. So you can choose between TF-IDF or TF, but for this model, we chose a term frequency inverse document vectorizer. So that was done successfully. And then further on the graphic, we performed a principal component analysis. And as you can see here, from the resampled data, that there are some explicit clusters. You can see here, so SDG 6 related nodes. And if we come here, that's SDG 7. But what's important to note, especially in this region, you can also see class overlaps. So here was SDG 16 overlapping with SDG 12. And also here at the bottom, we have a nice cluster of SDG 10. However, there are some blue dots that overlap with SDG 17. This really shows you how the SDGs overlap over each other, which then would present a challenge for the tool to give you, like exact classifications. And going down, so if I look on the sidebar, the model chosen is the random forest. Hence, the random forest is very nice, and because it offers explainable features such as this graph here, which really shows the features that the random forest uses. And from here, you can actually see the discriminative power of each feature that really drives the random forest model in its decision making in terms of classification or classifying. And then moving further down, as normal, we performed a confusion matrix for each model. And the F1 score for this particular model is 0.99, as shown there. Okay, and then the gem of the tool, it also allows you to then select any text. So we'll go ahead and select 13 and then start our prediction. And let's see how well this will classify. And we have to wait for about 15 seconds for it to give results. It's almost there. Okay, so we chose SDG 13, and our results say the closest SDG is SDG 13. And then we went further due to the model possibly having overlaps between the SDGs, we also provide you with the next top 3 predictions, which in this case was SDG 12, 14, and 13. And yeah, that's pretty much how the tool works. Thank you. Over back to you, Lamont.
Thank you, Khutso, for that great demonstration. Just to close out then, our next steps that we have for this project is to include the indicator metadata, findings that it is possible to classify research according to SDG goals, provided we can concatenate the target descriptions and balance the data set.